Suppose you want to create a password using 3 letters followed by 2 digits. How many passwords are possible? Are you really going to list them all? Of course not. Today, you'll learn 2 powerful counting tools that are the foundation for permutations, combinations, and probability. First, the multiplication counting rule. If one event can happen in m ways and a second event can happen in n ways, then both events can happen in m times n ways. More generally, multiply the number of choices for each step. This rule extends to any number of events. Just keep multiplying. This simple principle unlocks the ability to count enormous possibilities without listing every single one. For example, you have 3 shirts and 4 pairs of pants. How many outfits can you make? For each shirt, there are 4 pants choices. So apply the multiplication counting rule. 3 shirts times 4 pants equals 12 total outfits. In this case, there are 12 possible outfits. Or for this next example, a shop offers 5 flavors and 3 cone types. How many different orders are possible? You'll simply do 5 times 3, which would make 15 possible choices. Or for a license plate, a plate has 2 letters followed by 3 digits, where repetition is allowed. For the letters, that will be 26 times 26, which is 676. For the digits, you'll multiply 10 times 10 times 10, which will be 1000. So in total, that will be 676 times 1000, which will be 676,000 possible license plates. Now let's talk about factorials. When arranging objects, factorials appear naturally. For any possible integer n factorial, the exclamation mark is called factorial. So n factorial will be equal to n times n minus 1 times n minus 2 times n minus 3, and you'll keep going until you get times 2 times 1. 5 factorial will be equal to 5 times 4 times 3 times 2 times 1, which will be equal to 120. 4 factorial will be equal to 4 times 3 times 2 times 1, which is 24. 3 factorial will be equal to 3 times 2 times 1, which equals 6. You get the idea. Now 0 factorial is a special case. 0 factorial will be equal to 1. That makes counting formulas work correctly. For example, how many ways can 4 different books be arranged on a shelf? So for the first position, you'll have 4 choices. But once you put the first book down, for the second position, there's only 3 choices left. For the third position, you'll have 2 books to choose from. And for the fourth position, there'll only be 1 book left. So using the multiplication counting rule, that'll be 4 times 3 times 2 times 1, which is 4 factorial. So in this case, you'll have 24 arrangements. How many ways can 6 students stand in a line? Each position reduces the remaining choices by 1. So we'll apply the factorial directly. 6 factorial will be equal to 6 times 5 times 4 times 3 times 2 times 1, which will be 720. There are 720 possible arrangements for 6 students in a line. When arranging all objects in a sequence, the answer is always n factorial. Now, sometimes you may have a question like this. Evaluate 8 factorial over 6 factorial. That's a common type of problem in counting and probability. So step number 1 will be to expand. 8 factorial you could rewrite as 8 times 7 times 6 factorial, and 6 factorial in the denominator will remain 6 factorial. Now you can simply cancel 6 factorial in the numerator and in the denominator, and you'll be left with 8 times 7, which is 56. The key insight here is to expand just enough to cancel the repeated factorial. No need to compute large numbers. Here are your challenge problems for today. Pause and try both problems before reading the solutions. First, we have the mascot outfit problem. A school mascot has 4 hats, 3 shirts, and 2 pairs of shoes. How many different outfits can the mascot wear? And then we have the student lineup problem. How many ways can 5 students line up for a photo? Here are your solutions. For the mascot, you'll apply the multiplication counting rule across all 3 choices. So that'll be 4 times 3 times 2, which is 24 different outfits. For the student in line, in order to arrange all 5 students, we'll use a factorial. 5 factorial will be equal to 120. That will be 120 arrangements. So here's your fast track memory trick. The multiplication counting rule, you multiply the number of choices at each step to find the total outcomes. And for factorials, if you're placing all objects in order, you'll use n factorial. But now you may ask, what if order matters? That's where permutations come in. In the next lesson, we'll build directly on the multiplication counting rule and factorials to answer questions where the sequence of choices make a difference. Stay tuned. Permutations, combinations, and probability are all within reach now that you have these 2 foundational tools. Thanks for watching. Please like and subscribe to keep learning with us. And don't forget, math success starts when you stay on the fast track.